Do we really need genetically modified foods? This question is not being asked enough over the past 2 decades. 2 decades that have seen the introduction of GM crops onto our farms and into our diets. In these 20 years, there have been arguments for and against the use of GM crops. There have been studies showing how effective GM crops can be in increasing annual yields and how GM crops can harm the environment and humans. In these 20 years, we've also seen a steady increase in the use of GM crops worldwide, as this table shows. The question, do we need GM foods, must be answered. But I will not attempt to do that. I'm only going to look at the record and try to determine whether we have taken the right or the wrong approach, whether we have adopted the required precautionary principle, as UN nations ratified in 1992 at the Rio Earth Summit, and to see how two seemingly similar nations can have such a different stance on the use of GM foods. Firstly, we'll look at what GM food claims to be able to achieve. Producers claim that GM crops can increase the yield, as the crop no longer has to deal with pressures that historically affected them. They claim that herbicide-resistant crops, such as Monsanto's Roundup Ready soy and canola, will have an increased yield, as farms can be sprayed for weeds and the crop will survive. This argument lacks sense, as weeds were sprayed or removed in the past. It was just done on the ground instead of by crop dusting. This method really only reduces labour and associated labour costs with weed eradication. This method also means that there is a continued and potential increase of use of herbicides, which are known to persist in the environment and have the potential to harm humans, and they've created superweeds, weeds that are now resistant to the herbicide. However, this method can lead to a reduction in costs for the consumer, as labour costs have been reduced, thus giving access to food to more people. Producers also claim that the yield can be increased by inserting certain bacterial genes into certain crop DNA, giving the plant innate insecticidal properties, thus meaning herbicides are not necessary. This seems like a great method of modification, except that it has been shown that the inserted gene in these crops can persist in the environment, causing substantial problems with runoff after crops have been harvested and the waste left in the field, a common practice on most farms. In India, it has been shown that runoff from a farm growing BT maize, another Monsanto product, has all but killed aquatic and insect life in a nearby creek due to the persistent bacterial gene in the maize. Producers claim that because of these and other potential advantages, we can ensure food security in the future. Increased yields and food security are very important to both the agricultural industry and the world population, which, according to the UN, is said to pass 10 billion by 2100. Advancement in food production is necessary to ensure food shortages are not a common occurrence. Along with the previous examples, there are also more risks associated with GM crops, as shown here in this table. Next, in terms of ecologically sustainable development and the precautionary principle, we'll look at how both Australia and New Zealand have adopted or rejected GM foods. Both Australia and New Zealand operate under the same laws regarding genetically modified organisms, overseen by the Food Standards Australia and New Zealand. Food Standards state on their website that they will not approve a GM food unless it is safe to eat. Once a food is approved by Food Standards Australia and New Zealand, it is then down to each country as to whether they will allow the crop to be grown or not. To this point, New Zealand is yet to allow a GM crop to be grown, but Australia now has over 700,000 acres of land growing crops, consisting of canola, cotton and soy, among others. Australia's policy regarding genetically modified organism use is the Gene Technology Act of 2000, and New Zealand adheres to the Hazardous Substances and New Organisms Act of 1996. Unfortunately, for the food safety of Australia and New Zealand, the onus of proof of safety is on the producer, whereby it is the responsibility of companies that have developed GM foods to demonstrate the safety of that food, and to supply Food Safety Australia and New Zealand with the raw data from scientific studies to prove this. This in itself is problematic, as even though Food Safety Australia and New Zealand state that the science must be obtained using sound scientific methods, there is the potential for information or risks to be omitted. A producer can include and alternatively exclude data. Unfortunately, as Food Safety Australia and New Zealand is a government body, it is somewhat in their interest to approve new technologies, as this can lead to increased government revenue. Cynical? Yes, but also probable. However, if the food is deemed to be safe by Food Safety Australia and New Zealand, or at least present no risk to human health or the environment, it is then up to each country's own regulators as to whether it can be grown or not. Not surprisingly, Australia's Gene Technology Act and New Zealand's Hazardous Substances and New Organisms Act are quite similar in their licensing, management and risk mitigation requirements when considering approval for the use of GM food. Both countries have similar labelling laws where it must be stated that the product contains GM food, which allows for consumer choice. However, there are some loopholes in labelling laws, where food served in restaurants or takeaways are exempt, where livestock fed with GM seed is exempt, and highly refined foods such as oils, butter and baked goods are also exempt. These loopholes consequently reduce consumer choice. The question remains, why has Australia allowed GM crops and New Zealand hasn't? The answer is not clear. Australia and New Zealand are unique in the world, where they're both large land masses, isolated from other nations, have large export markets with large associated transport costs. The isolation that both countries have can be a blessing and a curse, but New Zealand has opted to embrace its isolation. New Zealand, not Australia, now has the potential to remain the one highly productive agricultural producer in the world to claim to be completely GM free. Many New Zealand farmers are wanting access to GM seed as they see it as a source of more income. They believe that the nation will fall behind in the world market without it, and that their costs will rise and the world will buy elsewhere. What they don't see is that they are able to build a market to which they are the exclusive beneficiaries. Just as the organic market is a worldwide success with constantly growing demand, so will be the GM-free market. Again, in terms of ecologically sustainable development and the precautionary principle, it seems that New Zealand is taking the correct approach, as there are many potential and unknown risks to human and environmental health associated with GMO use. Australia has looked at economics and how we can benefit financially without considering the people or the environment. The precautionary principle is just like the Hippocratic Oath, which all doctors take before being able to practice. Primum non nocere, first do no harm. Implied in this, and in all actions taken to ensure human health, is the principle that we must not act until it is proven to not harm. I believe that the governments worldwide have a duty to act as medical practitioners do, that they must first do no harm. So do we need GM foods? Well, it may be that we do, but worldwide it seems that we haven't followed the rules that we decided to adhere to. We have potentially forever put ourselves and the environment at risk, as there is no way to reverse the effects of releasing GMOs into the environment. They will persist as long as life does.